All right, hello, this is lecture video for lesson 1-2. Lesson 1-2 is titled More Geometric Figures. So we've done lesson 1-1, which was basic geometric figures, and we're moving on to some more geometric figures in this lesson, okay? All right, so let's start. Our first geometric figure is our adjacent angles, okay? Adjacent angles are two angles with a common side and a common vertex. So if we look at this picture we have right here, that's an example of adjacent angles. And then the adjacent angles actually in here are angle 1 and angle 2 are adjacent. Because remember, we can label angles with numbers, right? So 1 and 2 are adjacent because they share a common side, which would be this side right here, and then a common vertex, which is point S. Okay? All right, next we have vertical angles. Vertical angles are a pair of opposite angles formed by intersecting lines. So look at our example. Okay, so angle 3 and angle 5 are vertical angles. Also, not as low. Also, angle 4 and angle 6. Right, so this, if you look at them, it says it's a pair of angles formed by intersecting lines. These lines intersect to form the ones right across from each other. They're vertical angles. We'll actually show later on that vertical angles have the same measure, meaning that they are congruent, okay? We'll talk about what congruent means later on. You don't have to worry about that, but just know that they have the same measure. We'll prove that too. All right, next, complementary angles. Complementary angles. The sum of the measures of complementary angles is 90 degrees. So if you hear complementary, you know they add up to 90 degrees. So if we look at this, angle ADB, which is this angle right here, and angle BDC are complementary. And how do I know that? Because we see together these two angles form this right angle right here, and we know it's a right angle because of the square right here. We know a square right angle is 90 degrees, and we'll actually talk about that in just a second. We're going to define a right angle. Supplementary angles. So if we have complementary angles, the measures add up to 90 degrees. Supplementary angles, the measures add up to 180 degrees. So we look right here, angle 1, angle 2 are supplementary. So another way of writing this and showing that they're supplementary, you can say the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So this is another thing, a good thing to point out right now. This little m in front of an angle means measure of that angle. Okay, so if we do the same, we write the same thing for our complementary angles to the left right here. We could say the measure of angle ADB plus the measure of angle BDC is equal to 90 degrees. Okay, so remember that m means measure. Okay, next, an acute angle. Okay, this is a type of angle, and we're gonna talk about its degrees, or like what its measure is. Angle with measure greater than 0 and less than 90 degrees. Okay, and that generally looks something like this. Acute angles tend to look like something like that. Okay, so its measure is less than 90 degrees, but greater than 0. All right, similarly, we have a right angle. A right angle, we should know what a right angle is. It's an angle with a measure equal to 90 degrees. And what signifies that an angle is a right angle on a graph, on a picture, is that little box. Must have box. So that's what a 90-degree angle looks like. Okay, next, obtuse angle. So instead of being less than 90 degrees, we're greater than 90 degrees. An angle with measure greater than 90 and less than 180. So it's between 90 and 180. Generally, it looks something like this, right? Okay. All right, and then lastly, we have a straight angle. Straight angle is an angle with measure equal to 180 degrees. Why do we think they call it a straight angle? Because it's literally just a straight line. And that's a 180 degrees. A 180 degree line is a straight line. And you can see that in the supplementary angles, the two angles together, they formed that straight line right there, and that's why they are supplementary. Okay? All right. All these definitions are important to remember, okay? We will have vocab tests, and these will be on the vocab test as well. So, all right. So what we're going to do is complete the chart by naming all of the listed angles, angle types in each figure. Okay, so first we're going to deal with this one right here. All right, so let's try to find what the acute angles are in this figure right here. Remember, we said acute angles kind of look like this, right? Less than 90 degrees and greater than 0 degrees. So in this one, it looks to me like the only acute angles are angle 8 and angle 9. Okay? Now the obtuse angles, angle 7 and angle 10, are going to be our obtuse angles. Because remember, an obtuse angle looks like this. So this is acute, obtuse. All right, angles with the same measure. So if I go back and remember look at our definitions on your note page. What did I say about vertical angles? I said that vertical angles are going to have the same measure. We'll prove that later on, but they do have the same measure. So one pair of angles with the same measure, angle 8 and angle 9. They're vertical angles. They look like they're the same, don't they? And they are. Their vertical angles have the same measure. So similarly, angle 7 and angle 10. Just put this little note here that those are vertical angles. All right, supplementary angles. Remember, two angles to form a straight line when you look at the picture are supplementary angles. So I could say that angle 8 and angle 7 are supplementary. Okay, but then 7 also makes it a straight line with 9. So 9 and 10. And we'll go back, we'll just check. So I actually did not put 2 on here that I needed to. Angle 7 and angle 9, right? They are supplementary. They form a straight line. We said 9 and 10, but then angle 10 and angle 8 as well. Okay, go ahead and put that on there. Then the complementary angles, you see that I kind of jumped the gun here, but I said there's none, and because there's not enough information. Okay, I don't see anywhere on my picture any two angles forming a box, right? So I do not know the actual angle measure of 8 and 9 or 7 and 10. Okay, they could 7 plus or 8 plus 9 could possibly add up to 90 degrees, but we just do not know for sure. So we're going to say none because there's not enough information. Okay, and that's because we don't know the specific measures of those angles. Okay, all right, let's do the harder one now. We've got this beautiful picture right here. Let's talk about what the acute angles are. Remember they look like this. So angle ABF, I agree. Oh, what else we got? Angle DBE, sure, that looks acute to me. And then we have one more, CBD, okay? Those are our three acute angles here. Our obtuse angles now. So you got to be careful with this one, okay? We're going to do the ones that look obvious first. FBE, right? That looks like an obtuse angle. Cool. What's next? FBC. FBC. So this angle right here, it's kind of hidden because this one's in the middle, but that's still an angle. FBC is an obtuse angle, so I'll take that. Next, ABD. Okay, that's also obtuse. Looks good to me. So just a reminder, when we're looking at angles with three letters, remember the way I always do it. I start at the point where the angle starts with A, then I move over to the vertex B, and then I go up like that. I just follow A, B, D. Okay. All right. What else we got? Do we got any more? No. Okay. Cool. So angles with the same measure now. Well, my first one we had is ABD, and then FBE. We know those are because they are vertical angles because they are formed by two intersecting lines. Cool. That's cool with me. What else? How about ABF and DBE? That's another two vertical angles right there, right? Okay, that looks good to me. Are we finished? How about, so this is a right angle, right? And it's supplementary with that one, so this is also a right angle. So ABC, that's what I said, and CBE, both right angles. Right angles have the same, if they're both right angles, they have the same measure. And we got one more. How about two straight angles here, right? Angle ABE and angle DBF. Okay? Those are four pairs of angles with the same measure. Supplementary angles now. ABC and CBE. There you go. Very good. 90 plus 90 equals 180. So there you go. ABD and DBE. That works for me. They both make a straight line. FBA. And then ABD. Very good. Make a straight line as well. DBE and EBF. Okay, I'll take it. EBF and FBA. I'll take that as well. And is there one more? No. Okay, so that's all our supplementary angles, but we have our first pair of complementary angles now. So CBD and DBE. All right, they form this right angle right here that we know is a right angle. So, okay, are we finished with that one? You might think, yes, we're finished, but I know that this angle and this angle add up to 90, correct? But the funny thing is that I know that this angle and this angle are the same measure. So, if this plus this equals 90, then this one plus this one has to equal 90, and that's what we have next. Angle CBD and angle ABF are complementary. But, look, you're asking, they're not right next to each other. Think about it. Our definition of complementary angles does not say anything about them having to be right next to each other. So, as long as their measures add up to 90 degrees, we are good with that. They can be complementary. And that's it for this example, guys. P1 is done. Alright, so we're going to move on to some definitions about circles, okay? This stuff will be on the test, so pay attention. Know these definitions, please. The chord of a circle is a segment with both endpoints on the circle. Okay? So if I have a circle, and I have an endpoint right here, let's say, and an endpoint right here. You connect the dots, and that's a chord. This would also be a chord too, just as long as both endpoints are on the circle. Okay? Draw it better right here, maybe. Endpoint, endpoint, connect the dots. That's the chord. Okay. Now we're going to get a little more specific with stuff now. Diameter of a circle. I know we've probably heard of what a diameter is. It's a chord, so it is a chord that passes through the center of the circle. So the center of the circle is right here. So in order for it to pass through the center of the circle, if I have an endpoint right here, I have to go on the complete opposite side of the circle to find the other endpoint for a diameter, because it has to go through the center. Okay? Alright, cool. That's a diameter. Our last definition here is going to be a radius of a circle. Okay? Radius of a circle is a segment with one endpoint on the circle. So here's an endpoint on the circle, and one endpoint at the center of the circle. So for a radius, one of your endpoints is always the center of the circle. Okay? So look at that. Look at this. Remember we had our diameter that went all the way across? So if this is a radius, what can we say about the relationship between a diameter and a radius? So we'll call this D for diameter, call this radius R. The radius is always half of the diameter. Radius is always half of the diameter. That's a good thing to know. I would keep that in mind. I'm sure we might have heard that before too in other classes growing up, okay? So I'm going to erase this now because got this right here, okay? See, this is a radius, but you know what? This was also a radius, okay? There are a bunch of radiuses you can draw in this circle, and they're all the same length, okay? Diameter, chord, radius. Awesome. Let's look at P2. In the circle, draw and label each geometric term. Okay, so I have this circle here. I'm going to draw radius OA. Okay, radius OA. So I drew a radius. We're going to label this O and this A. Okay. The chord BA. All right, so I already have A written down. I just need to be a chord. It just has to have two endpoints on the edge of the circle. So I can just draw a point B somewhere on here, right? And I connect the dots. So that's chord BA. Okay, that works. And then diameter CA. All right. So what do I need to put the C at? I think I probably need to go over here to put the C, right across, because A is already over here, and for it to go all the way across, C is going to have to be on the exact opposite side. And that's what we have right there. Beautiful. So your drawing should look something like this. Okay, when you're doing this, I noticed that A, B, AA, and A was a point in all three of these. Okay, and all three of these have at least one endpoint on the edge of the circle. So A was going to be on that edge of the circle. That's how I knew O was going to be the center. And that's the next question. What is the geometric term for point O? It's the center of a circle. Okay. P3. The measure of angle A is 42. So I'm going to write this like this. Another way to say that is measure of angle A is equal to 42. Okay. What is the measure of an angle that is complementary to angle A? So we can do 90. I know that two angles that are complementary, that means their measures add up to 90 degrees. So if we subtract 42 from 90 degrees, I'll get an angle that is complementary to it, meaning it's 48 degrees. And to check if you want to, 42 plus 48 is equal to 90 degrees. Very good. That's what we wanted. All right. How about supplementary? So instead of 90 right here, we would just do 180 minus 42 to get 138. And if you want to check yourself again, you can do 42 plus 138 is of course equal to 180. Very good. Supplementary, remember the supplementary means their measures are add up to 180. Complementary means their measures add up to 90. All right, P4, our last problem. How many chords are shown in the figure below? So we've got this. So remember, chords are just a segment with both endpoints on the circle. So let's look. I said 2. We said 2. Let's check them out. So AF is one chord, and then CE is another chord. OD isn't a chord, it's a radius, and BO is not a chord, it's a radius. There are 2 chords in the figure below. And that is lesson 1-2. Your homework should be posted on OneNote and on Blackboard. It is due the following day on by 3:10 p.m. Do not be late with your homework, or it will be maximum half credit, and you know how I grade those homeworks. Okay. All right. If you have any questions, please go ahead and email me as well. Thank you.